face wasn't almost in it. I gotta make sure it's in it. I'll put you down. I'll float down here to the corner. Okay, week 4 again. Now we're on to SWYK 2 notes. Find the domain and range of the relation and determine whether it is a function. Might as well determine if it's a function right away. Drawn some vertical lines through there. Hey, looks like it passes the vertical line test. So it is a function. Well, that's the second part of the question. We do want to know about the domain of this thing. Domain, possible x values. All right, let's kind of shrink this up a little bit. Although, remember, we're going to draw everything. We're going to collapse everything down onto the x-axis and see how much of the x-axis gets covered. We know this thing keeps going up forever and ever and ever. It gets wider and wider and wider. So we're going to do this for a long way, right? A long way. Okay? So wouldn't it cover the entire x-axis if we dropped every single point straight down? That's what I really need you to focus on. If you want to know about the domain, I mean, we got billions of trillions of points here. We don't have just like 5 coordinates where we can just pick different x's. So we want to push them all down onto the x-axis and say, how much of that x-axis is getting covered? Well, in this case, it covers everything, right? So which one of those says all real numbers? All real numbers. Okay, now real numbers, remember, are the anything, right? We're talking decimals, fractions, nasty numbers, rational numbers, irrational numbers like the pi's and the radical 2's. And the nice numbers like 7 and 25 and -3. But that's the one right there that goes with all real numbers. So I know you're covering everything from the left to the right forever and ever and ever. Okay, now that's the range, or that's the domain. What about the range? Well, now I want to actually think about pushing all of the values onto the y-axis. So imagine just taking the graph, smashing it vertically right on that y-axis. And when we do that, how much of the y-axis would be covered? Well, I'm hoping that you would see that it starts at 0 and it goes up from there. So how do we say that? We want to say y is greater than or equal to 0, right? Starting at 0 and then going up, 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 up. Now, which one of my choices is that one? Well, if I take a look at this over here, I'm going to see that letter C is the one that we're talking about because it says everything bigger than 0 and it keeps going up to infinity. So that's the one you're looking for. Sorry for yawning. Okay, is the relation a function? We already determined that yes, it was. Okay, I already had that discussion. Okay, question 2. Is this graph a function, right? We got an absolute value function. We're going to do the same thing we did before, pass the vertical line through it. That's a definite yes, right? Because it passes. You do not have a vertical line that is hitting the graph more than once. Whoa. All right, now, not only are we, since we are talking about functions, we do want to throw in a story problem or two here. Recycled CDs Incorporated offers a choice of 5 used CDs for $27, with each additional CD costing $3. Write a cost function for purchasing 5 or more CDs. Now, let's focus on the function first. Ignore the rest of that stuff. When I go up, let's say I've got in my hand, I got 7 CDs, right? Well, the first 5 are going to get charged $27. After that, each additional CD is going to cost me $3. So $3 times however many I have that are over the first 5. In fact, and this is, people don't always get this function right, but some people do. And I'm hoping that you can do this because, I understand this is a before tax price, they're not considering taxes. But that's an important piece of information right there. Let X be the number of CDs over 5. Because people don't think about that. They don't say, okay, I got 7. Well, these 5 are going to get $27, and then these 2 over here are going to get charged $3. So when you get to this part of the question, what will the cost of buying 14 CDs actually be? A lot of people just put 14 in the equation. Well, they immediately end up losing on that particular question because they're not paying attention to what X is. So X is the number of CDs over 5. So 14 take away 5 means that we have 9 CDs that are over 5. So if we're going to use our function, 27 plus 3 times 9, which is 27 plus 27, or 54. And that's your answer to this question. You need to be able to figure out what sale prices are. When companies offer particular sales, if you don't know how to calculate percentages or, what is this really going to cost me? I have to buy this in order to get this. If you follow the directions, what's interesting is sometimes you get better deals. For instance, computers might be set up, oh, well, our computer says the cost is this. I need you to be smart enough to go, that's not what your sign says back there. Your sign says this. The store should honor that and say, well, yep, it says that. We'll have to take that sign down because that sale ended. Well, hey, you advertised it. You should uphold your end of the deal. Anyway, I want you to be smart people and save yourself some money. Have a great evening and get on that next SWYK, and I'll see you in the next video. Bye.